So for the third and final talk of the seminar, let me introduce Dr. Cynthia Furse. Dr. Cynthia Furse is professor in the Electrical and Computer Engineering Department at the University of Utah, USA. Dr. Furse is a fellow of the IEEE and the National Academy of Inventors. Her technological innovations and patents include development of a system to locate intermittent electrical faults on aging aircraft wiring, with which she founded a successful spin-off company Livewire Innovation. She is also a pioneering researcher in the development of telemetry antennas for medical implants and fast methods for predicting the statistical variation in bioelectromagnetic applications. She is a leader in the flipped classroom teaching method. She has received numerous teaching and research awards, including the 2009 IEEE Harriet B. Rigas Medal for Excellence in Teaching. I now hand over the session to Dr. Cynthia.
Well, thank you, and thank you very much for the invitation. I'm delighted to join you here in India from the University of Utah. Halfway around the world, it's night here, though it's morning there. So in my talk, I totally resonate with the things that Selvin has mentioned to you, as well as Hugo and Amanda. So I hope that you'll find that all of us are having similar experiences and encouraging you in your further career aspirations. So I want to talk about the power of failure and how getting it right, actually, you get it right by getting it wrong sometimes. And we'll talk about how to get an A in life. So let me introduce myself also. I'm Dr. Cynthia Furse. I am a professor at the University of Utah. I am a teacher. I was the Associate Vice President for Research, and I am an inventor. I'm a business executive, but most, I'm a wife, a mom, and a grandma. This is how the world sees me, and I think you'll find that I enjoy many students from India. I hope that you'll come and consider the University of Utah as well. But this is how I see myself. So when Dr. Selvin talked about considering the things that are really important in your life, it is very important to work, but it's important to work to live as opposed to live to work. So let's talk about success, and let's talk about failure too. So I'm going to actually start my example with something that's not related to engineering at all. This is my friend Monica. Monica Zoltansky ran for Sandy City Council. That's an elected position, and she wanted to make a difference in her city. So she ran for election, and you know what happened? When the end of the contest happened, she was so close. She was within almost 20 votes of getting her goal, but the person ahead of her had actually won, but not yet. Actually, by the time the mail-in votes got counted, Monica ended up winning her Sandy City Council. What I want to think about, though, is what do you think it felt like on the voting day when she was behind and when she was hoping so much for a win, but she didn't think she had gotten it? And then how do you think it happened when it changed? And she was expecting that she had almost won, but not quite. But yet she later found out that she had. Those are some pretty serious emotional ups and downs. So I think the importance of resiliency here was a big deal. Monica did win her position. She is currently a member of the Sandy City Council, and in fact, she's currently running for mayor. When I started my undergraduate program, I had a colleague, a friend, that I really wanted to help. He was in a wheelchair, and the way he controlled his wheelchair was by blowing into a little puffer tube. And it's very cold in Utah in the winter, and sometimes he would be, driving along campus, and his tube would freeze up, and we, the other engineering students, would have to help get him to class, get him into a building. So I really wanted to make a wheelchair that could be controlled by voice. So I worked so hard. I mean, this is many years ago, so please forgive the level of circuits that we were building, but I put together a circuit board where you could talk into it and you could say, go. And I didn't have a wheelchair. This is a picture of a wheelchair that's not mine. I didn't have a wheelchair, so I actually used a little toy car to be my representative wheelchair. And you could say go and it would go. You could say left and it would go left. You could say right and it would go right. It was so exciting. But you know what? It worked 98% of the time. Now, in any other world, that would be an A. I would have succeeded brilliantly if I got 98% in an engineering class. But for an electric wheelchair, if it works 98% of the time, that means that it fails 2% of the time. And if your failure means that it drives off the curb and takes the person into traffic and they are injured, that is a failure that cannot be tolerated. So my very successful design was actually a failure, but not quite. Because at 98%, it actually had a lot of potential, just not for a voice-controlled wheelchair. Instead, I sold the design to a local company that used it to plug in devices like fans and televisions and telephones, so the person who was in the wheelchair would be able to say 1 on, 2 off, and be able to turn devices on and off just by speaking to them. This is actually my colleague. This is the colleague for whom I was developing the wheelchair. He and I went to school together. And I was very pleased that 20 years later, I was able to have a team of undergraduates work with him to create something that we called the U-Hand. It's an assistive technology that allows people who are paraplegic, who are not able to get around their apartments, to be able to control the devices in their home just by speaking. Now, I can assure you, the devices now are far more advanced from the little one that I developed so many years ago. But my friend here remembered that device and contacted me and said, hey, do you have some smart students who would like to try this project? This, for me, was the greatest success of all, because this gentleman now runs the State Department for Assistive Technologies, and he helps people all over the state be able to improve their quality of life. So this wasn't just for him, it was for so many people in our state. When I did my master's in electrical engineering, we developed another technology, and it was for oil wells. This was when well drilling was very unpopular actually in the United States, and particularly the offshore, the ocean well drilling was of great concern because that's a strong risk for polluting the environment. And so one of the prime features in being able to run something like that is to make sure that you can extract as much oil, all the oil that would be possible, from this otherwise highly impactful process. So we developed a technology where you could put antennas down a well borehole, be able to heat the temperature just slightly, even 1/10 of a degree made a difference, so that more oil could be sucked out of that well. So when we developed that technology, unfortunately, at that time, I was not able to bring it back for my master's degree, and I was very concerned, how was I going to get my master's? My professor said, we are adapting this technology. And we adapted it from oil wells to hyperthermia treatment for brain cancer, a topic that I liked even better. And that was what my master's was actually on. It was only years later that I could say it was originally developed for use in oil wells. So let's talk about some of the aspects of success and failure. One of the real mantras here is it's really important to fail often and fail well. So do a nice big failure if you are going to fail. So I first want to just check in because I can't actually see the group. I want to be sure that you are able to hear me okay. Are there any problems? Are you able to hear all right? Alvin, are you able to hear me?
Cindy, yes,
Yes.
we are able to hear.
Okay.
Yeah.
Okay, great. Yeah. I just can't see it when I've got my slides, so I want to be sure I wasn't leaving you somewhere. So fail often and fail well, and I'm trying not to fail today. So another really important thing is choose important problems to work on. Now, important could mean important to your company, important could mean important to you. So choose problems that are important to you and to those around you. Choose problems that you actually don't know the answer to, and in fact, problems that nobody knows the answer to. For my PhD, I developed a software that allowed us to be able to find the fields in a human head from a cell phone. In the earliest days of cell phones, people didn't know if they were safe or dangerous. How would you know? So it was important to figure out how much of the electromagnetic field actually went into the head and where it went, so that biologists would be able to evaluate this and be able to tell us if it was safe or dangerous. And in fact, that is how the cell phone standards were developed. So this was a really, really important topic of the time. And it was a project that became very urgent because in the United States, there are a lot of lawyers, and a lawsuit came out where a woman had a brain tumor on the left side of her head where she held her cell phone, and suggested that that could be from the cell phone, but no one knew yes or no. When we did the evaluation, it turned out that no, that would not have been the cause of the tumor. That was very unfortunate that she had that, but it would not have been caused by the cell phone. But you can see this was a terribly important problem to her. It was an important problem to the people that wanted to sell cell phones. And it turns out it was an important problem to you too, because most of you have cell phones today. And without being able to answer this important problem, those couldn't be on the market. So choose other important problems as well. After I finished my PhD, this problem found me. When you fly in an airplane, there are miles and miles of wiring that are controlling many aspects of that aircraft. And that wire is going to be in there for as long as the plane is flying, like 20 years, 30 years, 40 years, and in some cases of military transport planes, up to 60 years. And as you can imagine, the wiring can actually become brittle, break, get damaged. The connectors can wear out. And you can end up with arcs and sparks that happen when the airplane is flying. There have been some very famous airplane crashes because of this, and there have been a lot more issues that you haven't heard about because the plane will just return back and they'll put you on another plane. There'll be no crash, no danger, but you can imagine the difficulty that this causes. So being able to find these faults is really important. Trouble is, the faults aren't happening on the ground. The plane is just sitting there nicely. It's when you go up and you get pressure on the wings, you get water and moisture, you get condensation. That's when you start getting the arcs and sparks. So you need to be able to find these faults in flight. But at the time we did this, no one was able to find faults in flight. We didn't have electrical test systems that worked on energized cables. You could measure the current, but you couldn't tell where the fault was. So if a fault happened and maybe a circuit breaker tripped, the pilot would say, be sure you check circuit number 2. The maintainer would check it when the airplane was down, everything would look fine. The problem only happened in the air. So developing a method that solved this very serious problem was one of the things that I've been able to make much of my career over. Now, another A I want to talk about is your comfort zone. Now, escaping your comfort zone is actually really, really important to your future success. All of us have places that we're comfortable. And when we start stretching that comfort zone, sometimes it feels like that's a hard thing, that's a difficult thing. But I want you to think of it as escaping that comfort zone so that you really have some opportunities. I had the chance to go to Antarctica to do electrical research. And at the time, I was quite intimidated by going on that project. The green containers that you see on the right, that's where we lived for a month in the snow and the ice and the cold. Yes, it really was this cold. This is me standing up. And it's another young woman who is crouched down. This is 2 ladies in Antarctica. And I was actually intimidated knowing that I was going with a bunch of young men. And how was I going to keep up? How was I going to pull the sledges? How was I going to carry the heavy things? So I worked really hard and I got myself in really good shape so that I could go to Antarctica on this grand research adventure. And I must say, by the time you're an old researcher, you've seen a lot of things. You've had a lot of experiences, and it can sometimes be hard to be a little bit wowed. But this escape from my comfort zone really did change my life and my attitude and my resilience. So let me please encourage you, don't be afraid to escape that comfort zone. Do it often. Well, let me tell you a bit about our experience in Antarctica. The problem with sea ice. In the winter, about 7 to 10% of the Earth's surface is ice. That's important. And our polar ice caps are some of the most sensitive regions on Earth. Sea ice is the boundary layer between the ocean and the atmosphere. And between 1980 and 2007, we had a nearly 40% loss of sea ice. We predict how much sea ice can be lost, but the truth is we're completely wrong. Of all the models that we have, you can see like 30 models here, none of them accurately predict the amount of ice that is lost. Every single model underestimates the amount of ice that is gone. So we wanted to see if there have to be other physical things that are not in the models that are contributing to the sea ice loss. So the area that we were interested in is melt ponds. This in the spring, when the ice starts to melt, you get these dark colored ponds that are up on top of the ice, and you can see that the snow is much more reflective of the solar gain. So what happens with these melt ponds is if you are there like measuring these melt ponds, they'll stay there like this, and then all of a sudden they just suck down through the ice. They disappear. They go from the dark melt pond back to white ice. The reason this happens is because the brine inclusions, the saltwater inclusions that are inside the ice, when seawater freezes, the fresh water makes the ice on the outside, and the salt becomes more and more intensely compacted into these little bubbles that you see right here called brine inclusions. Then gravity, through the freeze and thaw cycles, gradually pulls these down and helps them actually bridge like a tree or a pipe. So you can imagine this game. This is a popular game that some kids have really enjoyed. If you've got pipes, they don't do anything until they actually get connected. So it's kind of the freeze and thaw, freeze and thaw, freeze and thaw, pull, 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 until gradually you've ended up with a pipe that can allow the fluid from the melt pond to drain down to the ocean. This is a CAT scan, and you can see several of these brine inclusions, and you can start to see some of the bigger ones forming on the front that actually show you the pipes. Now, some of these pipes are millimeters in thickness, and some are as big as your finger. So there's plenty to be able to pull that water down to the ocean and return the dark ice back to white. So here we are on our first day in Antarctica. We arrived in Scott Base, which is run by New Zealand. We actually flew in through Australia. It was a delightful experience. This is my home where I left in November, and this is us flying into Christchurch, New Zealand. This is what I packed for the trip. Variety and resilience is the spice of life. So you have to be prepared for anything. Now, we got all of our clothes. They were actually contributed by New Zealand. You don't wear any of your own clothes out on the ice, only the things that they give you for safety. So we got all of our clothes, but you can see the palm trees here. We were in New Zealand dressing up for Antarctica. We had no idea what we were headed for. And this is us landing on the ice. Now, the interesting thing about landing a plane on the ice, you've surely landed on a plane on the tarmac, and you can feel the wheels that start to catch. But when you land on ice, there's no friction. This plane goes for miles, just floating along on zooming along on the ice before it finally gets enough traction to come down and to actually, stop and let everyone out. So it was cold. This is where we were. This is Mount Erebus. Mount Erebus is a volcano in the middle of Antarctica. So everything here is either white or it's volcanic black. Now, engineering is always an adventure. We work with very interesting people. This is the international research group from 6 different countries. And the most important thing that I learned about that was listen. Listen to your colleagues, talk a little, listen a lot, think a bit, listen, listen, listen. Hearing the ideas that the other researchers had about the ice that we were studying really generated a bunch of the creative ideas that we had in our research as well. This is our car on the side. It's called a Hageland. You can see that it has tracks instead of wheels, and the things that are up on the top, these silver things, whenever you'd come to a crevasse, a hole in the ice, you would take down those bridges and you'd lay them across the crevasse and then drive across. And don't worry, the people that were driving these would tell us, no, don't worry, this is perfectly safe. This was our home. It was K131. These are called Wanigans. They are refrigerated storage units, except that we had heat inside instead of cold. So we didn't actually live in tents, which was actually so much easier. It was very difficult if we had tried to do our lab without being able to have heat. But still, living in a refrigerated storage unit with you and 4 of your colleagues is a little bit challenging for a month, if I could say. These were our bunks right here. We each had a bunk to sleep in. The important thing here is you can adapt to anything. Be prepared to adapt throughout your career. It gives you such huge opportunities when you can look at it and say, there's an opportunity and I want to take it. And you can adapt to almost anything. We drilled sea ice cores. They were 2.5 meters deep. You can see one right here that's held by our Australian colleague. And then we would measure these sea ice cores with good old-fashioned nails and wires. We were measuring vertical resistance, and that was awesome. But we were really interested in the anisotropy, the difference in the ice between the vertical conductivity and the horizontal conductivity. And you can see from this CAT scan, remember that salt water is very conductive. So you can imagine that in this picture, as we start getting a lot of vertical conductivity, that's telling us that these brine channels are starting to connect. Electrical conductivity and fluid conductivity end up being very similar. So we could use electrical conductivity to predict what was going to happen with the water. So we really needed to know both vertical conductivity and horizontal because they told us major things that we were going to use for our sea ice model. So this is how it worked. In day 1, nothing worked. In fact, we blew the fuse for the entire camp. We had to put that back together. The DC measurements didn't work at all. The temperature probes corroded. Nothing worked. Simply nothing worked. In day 2, not very much worked either. In fact, we kept breaking our sea ice cores with our drill. Day 2, we did some figuring it out. We went back to some base theory, tried some of the ideas. We had tried it at home, but we didn't have true sea ice. When we started really evaluating what we were seeing, we had some ideas for the next day. So day 3, we had a little bit of success. Day 4, we wanted to try to get our horizontal measurements. So we tried a clamp-on measurement. It didn't work. And we tried this measurement, strapping things on either side. That didn't work. These were things we had planned on, but not the fact that they wouldn't work. And we tried nails to be able to measure the horizontal. That didn't work. And this sort of worked, but not very well. And this worked a little. And this worked a little. After filling 4 lab notebooks on multiple days, what do you think that felt like? My mathematician colleague, the professor who went with me is a mathematician, and he kept saying, but it works in theory. Of course it works in theory. It doesn't always work in practice. So what did that feel like? What sort of panic do you think we felt? What sort of concern, what sort of puzzlement? We struggled and we struggled and we thunk until our thunkers were sore. You know what? Science is not about working on things that are working. Because if it's working, it's probably not science. It's already figured out. Here's the iceberg illusion. When you see people that are successful, you think that that's what you see. But down below is a huge amount of risk. And what people don't see that led to that success is the persistence, the teamwork, the failure, the sacrifice, the out-of-the-box thinking, the disappointment, the discipline, the hard work, the dedication. That is the part of the iceberg that's the biggest of all. And that's what people don't see, but that's what it takes to have success. Let's talk about the imposter syndrome. It's one of the things that I like to share with students a lot, because especially students who are in really high achieving fields like you are, often feel that they have an imposter syndrome. I think that you'll recognize a bit of this from Hugo's talk too. So sometimes you think about the success that you had. You did really well on that exam, and you think, oh no, that was just lucky. I might be an imposter. I'm not sure when they're going to notice. I'm not really as good as they think that I am. That's being an imposter. It's called the imposter syndrome. You can look it up online. Please do. And if you suffer from this, please just recognize that this is a real feature, and you really can help yourself go beyond the imposter syndrome. It really is important to recognize the power of that optimism that Hugo and Amanda talked about, so that you can really recognize that you got that good exam score because of everything on the underside of the iceberg, because of your dedication, your risk-taking, your hard work. That is why you are successful. So please, if you think of this little imposter on the side, if it ever actually reaches you, it does me about every day. You have to remind yourself to chase away the imposter and recognize the success that you really are. Okay, back to the ice. We've been struggling with this, and I can assure you, we are all pretty stressed out about the fact that we are not able to measure the horizontal conductivity of the ice. But then we got creative. We were thinking outside the bowl. This is my cat. He's trying to get those goldfish. He's on the stairs, and he turns himself upside down, inside out, every possible way. He never did get the goldfish, but he sure made a mighty try. We were playing. We were messing around. We went sliding with it. The wind's very windy there. And just using one of our blue tarps, we were able to zip along on the ice like a sled. We did, in fact, have some snowball fights. We were playing and messing around. And in fact, what we were doing was teasing Ken, the math professor. He was the one doing the corer. And he wanted to core so straight, but he couldn't. He didn't core this crooked, but we were joking, Ken the crooked corer, Ken the crooked corer. We were teasing him. And then it occurred to us, Ken, if you really do make a really crooked core, it's going to have both the vertical component and the horizontal component. And with geometry, we can measure the horizontal component of the sea ice. And that is what worked. So the power of failure was try and fail and try and fail and try and fail as many times as it takes until you reach success. Failure is a very important tool in the path to reaching success. So dare to try, dare to fail, and dare to succeed. This is us when we went to the Arctic instead of the Antarctic. That's actually north instead of south. And in the North Pole, there are polar bears. One of the important things that we had to include in our budget was, in fact, our friend, the polar bear hunter. Now, in the gun, don't worry, it's not bullets. It's flares to chase away the polar bear until, yes, the last one is a bullet. We never had to even fire a flare at a bear because he kept us safe by staying on the radio and keeping track of the bears as we moved around. So this was a daring adventure, at least for me. And I do want to say, dare to try, because that is how you succeed. Another thing is dare to follow very famous footprints. Here's Mount Erebus again, and this is Scott, the ultimate explorer who originally found this area and whose base we stayed at, Scott Base. So follow in very famous footprints. It's okay. And then make some footprints yourself. Experience real life. So when you go to do science, get curious about all of the science that you see. Some of the people that were with us were studying penguins. This was a lovely penguin colony. Experience the real life here. Now, when you see this picture, what you see is me enjoying a really great chance to visit the penguins. What you don't see is, oh my gosh, these penguins stink. All of that gray, brown stuff that you see there, that's penguin poo. This place smells really, really bad. So when you are experiencing life, experience all of it. Relish all of it, and recognize it may not always be like what it looks like. Part of a village. These are the penguins, and you can see that the girl penguin lays her eggs in the middle, and then the boy penguins take care of them, all sitting around the outside. All of her friends come and make the nests right around the outside. So be part of a village, and don't be afraid to raise your eggs on the rocks. Penguins are the ultimate sign of resilience to me. They raise their little eggs and their little babies on what could be called love rocks, where they bring them together and they make a little nest out of rocks. And then relish the world's magic. I showed you the sea ice cores that were white. Well, actually, if you put those under platelets and you look at the ice crystals under a polarizer, this is what they look like. Inside, all of that white were magic, bright colors. Remember, Antarctica is all white and black. We had only seen things that were white and black for weeks. And then when we put the platelets under the polarizer, it was so exciting to see the bright and brilliant colors. So relish the world's magic. There is magic in this world. So when we talk about success, when we talk about failure, well, we all want the A. but sometimes we have to actually fail to get there. So let's talk about the A in life, not just the A in grades. Here's a definition of success that my dad really shared with me as a child. So let me share it with you. His definition of success is to laugh often and much, to win the respect of intelligent people and the affection of children, to earn the appreciation of honest critics and endure the betrayal of false friends, to appreciate beauty, to find the best in others, and to leave the world a little bit better, whether by a healthy child, a garden patch, or a redeemed social condition, and to know that even one life has breathed easier because you've lived. This is to have succeeded. This is to have gotten an A in life. So thank you very much for letting me join you today. I wonder if there are any things that you'd like to talk about. Any questions or thoughts?
Participants?
Cindy, I have one, wonderful storytelling kind of talk, very interesting. And the
Very
last poem,
motivating, actually.
very motivating. That poem, that last page, last slide, that's been exceptional. I have just captured a picture of that. Thank you
I
for
too.
that. That's all. No specific questions from me. Yeah.
Okay. And I'll be glad to share that with you should you need the slide and not just the picture.
Participants, any questions?
I hope you won't be afraid and shy to ask, because I'd love to talk with you.
Excuse me, ma'am.
Yes.
Good morning, ma'am. I'm Muthuvelan from Mechanical Department back in SSN, ma'am. Yes, I have a question to ask with you, ma'am. Ma'am, am I audible?
Yes, I can hear you. Sure.
Yes, ma'am. You told success is not overnight. You just telling that repeated means of trying the way will achieve success. But when we are facing failure, how to handle it, ma'am? How can we motivate ourselves try the next time? Uh, how to motivate ourselves to try the next level like that, ma'am?
Oh, that is a very good question. Listen to Hugo's talk. He and Amanda had some good suggestions, but I think that you have to develop your own personal experience handling failure and recognize it when it happens. So I know you'll see that you failed the exam. Someone else told you that you got 20%. That's a pretty harsh thing to see. Sometimes we look at that and we start fighting it. We're like, I didn't really deserve 20%. They made a mistake. Well, you should check and see, did they make a mistake? Or sometimes you'll say, oh, I give up. There is no way I can ever do this. And that is never true, actually. Sometimes it may take more time. Always, it will take more time. It may take more energy, but the important thing is to look at that failure not as we're used to. I mean, we're taught that failure is like the end, you failed. Instead, see that failure as a stepping stone, like walking up the steps to one of the beautiful Indian temples. There are a lot of steps. I've been there, I know. So consider each failure to be one more step, one more step. Thank goodness I don't have to try that again. Thank goodness I don't have to try that again. So keep trying and recognize it as a step instead of as an end. And I think that's actually what helps me the most, is to see it as a critical step to my success. By the time you're working on a real engineering project, a big project, or a master's degree or a PhD, it is not going to work the first time. In fact, it's probably not going to work the 10th time, which means your first failure, you've still got 9 to go or 29 to go. So you might as well just get on with it. So as soon as you start recognizing it as a key, critical, important learning step, I think it completely changes the conversation and the conversation that you have with yourself. So value failure, embrace it, and recognize it for what it really is, which isn't the end, it's actually a step. Does that help?
Yes, ma'am. Yes, ma'am. It was really motivating, ma'am. Thank you. I got it. I will try it, ma'am, in real life experience. Yes, ma'am.
And realistically, we do, all of us, even all of the old ones of us. Every time a failure comes, it feels just as ugly as it did the last time. But the important thing is to use your mind and your recognition to feel the pain and then move on.
Yes, ma'am. That is life. Yeah, I understand. Yeah. Yes, ma'am. Thank you for the wonderful explanation.
Wonderful question. Thank you.
Welcome.
Good morning, ma'am.
Yes.
This is Jansi Rani from Computer Science Department, ma'am. I'm a faculty here. Nice meeting you, ma'am. It's a very inspiring talk. I'm very happy to see you being a wife, mom, and a grandmom. And your, I think you. What I want to ask is, ma'am, can you provide us with some tips for balancing the professional life and the personal life? Because this the whole objective of the workshop is to have it like psychological capital, how to improvise our psychological capital. So I believe that the psychological capital have two broad spectrum. One is for our professional life, other one is for our personal life. So since I met you playing all the three roles, I would like to hear from you some tips, ma'am.
I wish I had perfect tips. The question is about balancing work and life, which is always 100% of a challenge. And whether you have, your first few years in school and you don't have a family at all, then once you have a family and you have a young career, and even later when your children have grown and you're now more senior, you may not have the children, but you have other responsibilities instead. This is a huge challenge for all of us to balance our personal and our professional life. And we all have to make our own decisions about where that balance point is. As a senior faculty, I am extremely concerned and really try to look out for my junior colleagues and our graduate students and our undergraduate students, because there is a temptation. I'm going to say a temptation, but it's not something we should give into. It's a temptation to think that if we work all the time, we somehow will be better at our work. Now, it's true, if I work all the time, I might write one more paper or I might write one more grant proposal, but I am not going to be a better engineer. The best that I can be is by being balanced enough that I can allow my mind to do the really tough thinking jobs that it needs to do. So I don't know if you've had this experience where you work on something so hard, you work, you try, you fail, you work, you fail, you're working like crazy, you're trying everything, you've got good ideas, you try them, they still don't work. And then you go home and you take a shower and suddenly the right idea comes, the idea that actually solves this problem. Or in my case, you see that I like to ride horses. I have 3 beautiful horses. And I can work so hard on something and just not solve it. But if I go out riding and I let my mind take that release and that break, then the idea comes. So if we don't balance, we aren't actually going to be as good. We are not going to be as intellectually strong. So the importance of balance is critical to our lives, to our families, to my husband, to my children, to my dog, to my horses. It's critically important to our life, but it's also critically important to our work. So the concept that I like to challenge is it's not work or family. You put the two of those together and you become a whole person. You are actually going to be better at both. So that's a key thing to keep in mind, is how to keep your mind healthy. Just like an athlete has to keep their body healthy, we have to keep our mind healthy so that we can actually be the most intellectually successful that we can be. Now, how to do that? Okay, so hours, time is the most valuable thing that we own, and you own it. You actually own your hours. You have 24 hours every day, 365 days a year, but you don't get 366, and you don't get 25 hours. So the greatest most valuable thing you have is time. So you should consider every day what the most valuable things to you that you're going to do are. Now, sometimes you have to do things that are terribly valuable to everyone else, such as go to the grocery store. You may not feel like the most valuable thing to you, but somebody's got to do it. Okay, so it may not be your most favorite thing, but it may still be really important because you have to eat, and so does your family. So choose the most valuable things, prioritize in your family life and prioritize in your professional life. So for example, I don't have a television. I've never had a television. I don't watch television. I spend my time playing in the mountains, running, walking, riding horses, out with a dog, or I spend my time thinking and working. I don't want to watch television. Now, some may, and that's okay. But for me, I have prioritized not to spend my time in that way. I choose instead to spend my time in this way instead of watching late night television. So choose priorities and make strong selections, and then write it down. So write down on your fridge, on your phone, on your calendar, wherever, this is what I want to do today. Now, the nice thing about lists like that is you probably won't finish them. So what you want to do today, if it doesn't get done, put it on the list for tomorrow, or decide that it's not important enough to do. That is okay too. So prioritization, I think, is the single most important thing to that work-life balance. And then the other thing is limits. Your work will eat you up. You absolutely can spend every single second on your work for the rest of your life. You could, but do you want to? So if you decide, I am going to start work this morning at 9 and I am going to finish at 3 and go horseback riding, and I'm going to be back at 8 o'clock at night and I'm going to work until midnight, that is what I do. Everybody has their own different schedule, but make your schedule, plan it, execute it, and do it. And in the time that you have planned to spend time with your kids, with your grandkids, with your family, whatever, do it. Like, put it on your calendar, and it's a meeting that you have to go to. You actually have to go play with your kids. So prioritize your family like you do your work, and don't let your work eat you up. So I think prioritization and planning are the two biggest things. And then to recognize there actually isn't a balance. No matter what you're spending time on, you could be thinking while you're playing with your kids, oh my gosh, I've got to get that paper finished. Or while you're finishing that paper, you could be thinking, oh, I've got to work with my kids, got to go play with my kids. So instead, be in the moment. So when you are playing with your kids, be there emotionally and really, and enjoy it. And don't be feeling guilty that you're not working on that paper. Then when you're working on the paper, pay intense attention to that, and don't be feeling guilty that you're not playing with your kids. Plan it, execute it, and then be in that moment and really deeply enjoy it. So those are about the best I can do. And even then, it doesn't feel balanced, even to me now. So it may still not feel balanced, but it will be pretty balanced if you're able to do those things.
That's really wonderful, ma'am. Thank you for your tips, ma'am.
Thank you for the question.
Any more questions? So I hope there are no more questions. That was really a motivating and inspirational talk. Thank you very much for sharing your experiences, Dr. Cynthia. I am sure everyone here will dare to try and fail and thereby reaching their success. Very, very thank you. Very thank you.
Thank you. So thank you. And it's delightful to get to spend the evening with you. Morning in your place. Thank you.
So Ramani, you can just some closing comments for the entire seminar, and then feedback you can request. participant feedback.
So participants, thank you so much for joining in. And I have posted the feedback form in the chat box. So take some time and kindly provide your feedback. That will be really helpful for us so that we can plan many more sessions like this. Thank you for your time. Thank you so much.
So thank you, Ramani, for very beautifully anchoring the program. Thank you very much, Cindy, for joining. It is 12 o'clock for you, right? 12 midnight. Thank you, Hugo and Amanda. Thank you very much for joining for the wonderful sessions. So I will just get in touch with by email in a short while from now. Thanks a lot. Thank you very much again.
Thank you so much.
Yeah.
Thank you very much.
Thank you.
Yeah.
Thank you.
Bye then.
Bye.
Bye. Ramani, I will leave, right?
Yes.
Yeah. Bye.
Thank you, everyone.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am. Harmony, ma'am.